Hi, my name is Tanga and my mention number is S74253. So today we'll present about our industrial visit to the Kemaman Biogas plant that is operated by the Concord Biotech. So Malaysia is one of the world's largest producer of the palm oil. However, the production of the palm oil also generates palm oil meal effluent, or it's called POME. So during the process of the fresh fruit branches, as we know that pomade contain high concentration of organic matter, suspended solids, and oil and grease. If it discharged without a proper treatment, it can cause serious environmental pollution due to its high BOD and COD. So one of the most effective method that can be treat the pomade is called anaerobic digestions, and it can break down the microenzyme matter by absence of oxygen and produce biogas. So it can turn into a renewable energy as we know. So as we visit to the Kemaman Biogas, is understanding about the pomade treatment and how it's treat the pomade and how they generate the electricity.
Assalamualaikum warahmatullahi wabarakatuh. My name is Norin Hazira, metric number S75453. So we move with Kemaman Biogas plant profile. First, let's look at the background. TDM Plantation Sdn Berhad currently operates two fully operational biogas power plants. They are located in Sungai Tung Setiu and right here in Kampung Padang, Kubu, Kemaman. Technically, these plants use a modern closed lagoon system to collect methane gas from organic waste through an anaerobic process. From this process, the plant continuously generates 2 megawatts of electricity per hour, which is supplied directly into the Tenaga Nasional Berhad or TNB grid. Moving on to the Concord Biogas plant or CBT performance, this specific plant in Kampung Padang Kubu started its commercial operations on March 12, 2022. It is equipped with two high-technology engines powered entirely by palm oil mill effluent, also known as POME, with a total capacity of 2.404 megawatts. This operation successfully prevents more than 22,000 metric tons of carbon dioxide from escaping into our atmosphere, making it a major contributor to our government's green goals.
My name is Nit Masara at 76525. Next, I will present about wastewater treatment and biogas production process. In this section, I will explain the process flow of wastewater treatment and biogas production at the Kemaman Biogas plant. The plant treats palm oil meal effluent or POME using a covered anaerobic digestion system. This process not only reduces the pollution load in wastewater but also recover methane-rich biogas as a renewable energy source. The treatment process begins at the POME feeding pit and continues through several treatment units like cooling tower, distribution tank, covered by digester lagoon, settling pot, and more before the treated effluent is safely discharged. At the same time, biogas produced during the treatment process is collected, purified, and converted into electricity. The wastewater treatment process starts with raw POME. Is collected at a POME feeding pit. Since freshly discharged, POME has a high temperature. It is first sent to the cooling tower where the temperature is reduced to approximately 30 to 37 degrees Celsius. This temperature range is ideal for anaerobic microorganisms. Next, the wastewater flow into the distribution tank, which regulates the flow before entering the covered biodigester lagoon. Inside the biodigester lagoon, anaerobic microorganisms break down organic matter in the absence of oxygen. This process significantly reduces the chemical oxygen demand or COD and biochemical oxygen demand or BOD of the wastewater. To improve treatment efficiency, the system uses internal and external recirculation tank. These units help maintain stable microbial activity and enhance biogas production. After treatment, the wastewater enters the settling pot where suspended solids settle naturally. Finally, the treated effluent is stored in the treated effluent tank before discharge according to the environment regulation. Biogas production occurs naturally during the anaerobic digestion of organic matter present in POME. This biological process consists of four main stages. The first stage is hydrolysis, where complex organic compounds such as carbohydrates, protein, and lipids are broken down into simpler compounds. The second stage is acidogenesis. During this stage, the soluble compounds are converted into volatile fatty acid, hydrogen, carbon dioxide, and alcohol. The third stage is acetogenesis, where these intermediate products are further converted into acetic acid and hydrogen, also carbon dioxide. Finally, in the methanogenesis stage, methanogenetic microorganisms converted this compound into methane and carbon dioxide, which forming biogas. Typically, the biogas produced contains approximately 50 to 80% methane, which serves as the main energy source. After biogas is generated, it undergoes several treatment processes before it can be used for energy generation. First, the raw biogas is sent to the biological H2S remover or scrubber. This unit removes hydrogen sulfide gas, which can cause corrosion in equipment. Next, the biogas passes through a chiller where moisture is removed through condensation. This improves the quality and combustion efficiency of the biogas. The treated biogas is then distributed to the biogas distribution system and supplied to the gas engine 1 and gas engine 2. Inside the gas engine, methane-rich biogas is combusted to generate electricity, which is used for plant operation. When biogas produce exceeds the capacity of the engine, the excess gas is safely burned in the flame system. This prevents methane, a potent greenhouse gas, from being released into the atmosphere. This slide summarizes the major equipment used in the Kemaman biogas plant and their respective function in the wastewater treatment and biogas production process. The process begins at the pomer feeding feed, where raw palm oil meal effluent is collected before entering the treatment system. The wastewater that then pass through the cooling tower, which reduces its temperature to an optimal range suitable for anaerobic microbial activity. Next, the wastewater enters the distribution tank, where the flow is regulated before being evenly distributed into the covered biodigester lagoon. This lagoon is the most important component of a system because it serves as the primary anaerobic reactor. Here, microorganisms break down organic matter and produce methane-rich biogas under oxygen-free condition. To enhance treatment efficiency, the plant utilizes internal recirculation and external recirculation tank, which help improve mixing, stabilize microbial activity, and increase digestion performance. After anaerobic treatment, the wastewater flow into the satellite tank, where suspended solids settle naturally by gravity. The treated wastewater is then stored in the treated effluent tank before final discharge. For biogas treatment, the raw biogas first passes through the biological H2S remover, also known as a scrubber, where hydrogen sulfide is removed to improve gas quality and prevent equipment corrosion. The biogas then enters the chiller, where it removes moisture through condensation. The treated biogas is supplied to gas engine 1 and gas engine 2, where it is converted into electrical energy. Any excess biogas that cannot be utilized is safely combusted in the flare system, which preventing methane emission and ensuring safe plant operation. Overall, these components work together to achieve efficiency wastewater treatment, renewable energy generation, and sustainable waste management.
Assalamualaikum, my name is Nur Aini Sofia binti Hairi. My metric number is S75137. So today I will be presenting section 4.0, which focuses on the electricity power generation system at the TDM Kemaman oil biogas plant. First, let's look at how biogas is utilized. At this plant, organic waste gases are not just left to escape into atmosphere as harmful greenhouse gases. Instead, they are captured efficiently. This biogas is highly valuable because it contains a high methane content, typically around 50% to 60%, making it an excellent alternative fuel. By adopting this waste-to-energy concept, the plant does not only replace conventional fossil fuel and control localized odor in the Kemaman area, but it also successfully generates clean electricity to power its internal operations sustainably. Moving on to cover this role, biogas into electricity, the plant relies on four main technical components. The process kicks off at the gas pretreatment unit or known as scrubber. Here, most endangered impurities like hydrogen sulfide are thoroughly filtered out to prevent severe internal engine corrosion. Once clean, the gas enters the biogas engine generator or genset. This internal combustion engine converts the thermal energy from burning the gas into mechanical rotational energy. This movement then drives a high-efficiency alternator to generate stable electrical power. The entire automated operation is managed via a centralized SCADA control panel, which continuously monitors voltage stability, handle load distribution, and execute safety shutdown protocols if needed. So our final slide details the actual power generation mechanism and the commercial model based on the real-time schedule monitor data we observed during our visit. The TDM Kemaman plant utilized a dual engine setup, meaning gas engine 1 and gas engine 2 run simultaneously at a speed of about 1500 rpm. Each of these engines produces an active power output of approximately 1.0 MW, specifically ranging between 999 kW to 1001 kW, delivering a stable three-phase alternating current at 411 to 412 volts at a standard frequency of 50 Hz. On the commercial side, while a fraction of this power is used to sustain the plant's own operations, the vast majority of this green energy is exported directly to the national grid through a power purchase agreement with Tenaga Nasional Subsidi Berhad. This framework also TNB to buy the electricity, creating a highly lucrative and sustainable revenue system for the company. That's conclude my part on the power generation system. Thank you.
Now let's talk about the sustainability aspects and environmental impacts of this project. There are four main pillars here. The first one is the reduction of water and air pollution. The plant treats raw pomade to drastically lower its high biochemical oxygen demands or BOD levels before it is discharged. This directly protects local river life and water resources. At the same time, the fully closed lagoon design acts as a physical barrier that completely blocks foul odors from affecting the nearby Kampung Padang Kubu community. The second pillar is resources recovery. The nutrient-rich solid residue or sludge is dry and turned into high-quality organic fertilizer for nearby oil palm plantation. Also, the treated wastewater that meets environmental standard is recycled and reused for domestic cleaning activities around the factory. The third pillar is the circular economy. This plant perfectly applies the waste to wealth concept by transforming pomade from an operational liability into a high-value green energy asset. Since March 2022, it has successfully generated over 29,000 megawatt per hours of clean electricity for the commercial market. Finally, the fourth pillar is the reduction of greenhouse gas emission. Instead of letting methane gas release freely from open ponds, this plant efficiently captures the gas to generate clean power, helping to fight climate change.
Observation and the discussion based on our field visit to the Kemaman Biogas plant, we observe how palm oil mill effluent or pomer is converted into biogas through anaerobic digestion. The plant effectively generates renewable energy while reducing waste. However, challenges such as pH fluctuation due to rainfall, sulfur and moisture removal, equipment maintenance, odor control, and lagoon membrane damage were identified. To improve performance, we recommend enhanced monitoring system, preventive and maintenance, stronger lagoon cover, and IoT-based technology. Overall, the plan demonstrates a suitable and efficient waste-to-energy solution.
So, as we know that, first is about the pH and temperature control should be closely monitored, especially during the rainy periods. Rainwater can enter and expose the treatment units, so it can dilute the pomade and reducing the pH level. So this can affect the microbial activity and lower biogas production. So more frequent of monitoring, partially covering of open treatment units are recommended. Next is about the quality of biogas can be improved by enhancing the sulfur and moisture removal system. So as we know that the sulfur compound will be clogged over time when it's to remove the sulfur in the productions. So beside that, efficient moisture removal is also important to reduce the corrosion and protect the equipment such as the turbine and compressors. Third, preventive maintenance should be strengthened. Equipment such as a pump, pipelines, coupling, and turbine operators continuously and are exposed to the harsh condition. So, predictive maintenance method, including vibrational monitoring and condition monitoring, it can help the reduce unexpected breakdowns. Besides that, we should purchase about high quality products to prevent frequent maintenance. In addition, odor emissions should be minimized by improving the gas contaminant system, upgrading the biofiltration units, and enhancing odor control technologies. So this will reduce the environmental nuisance to nearby communities. So another important issue is the lagoon covering membrane. So as we know that the current membrane canvas is about 3 mm, so it's occur occasional tears and causing the methane leakage. So replacing it with a stronger reinforced membrane and conducting routine inspection can help prevent the greenhouse gas emissions. So at last, future improvements that can be conducted by implementing IoT-based monitoring system for real-time tracking of pH, temperature, and pressure. For beside that, the gas flow rate also. So the plant may be consider using a combined heat and power or CHP systems to maximize the energy recovery from the biogas.
For the conclusion, is anaerobic digestion is an effective and suitable method for treating palm oil mill effluent or pomade by producing renewable energy in the form of biogas. Our visit to the Kemaman biogas plant provide valuable exposure to the complete process of wastewater treatment, biogas production, and electricity generation. Despite challenges such as process stability, gas purification, and equipment maintenance, the plant demonstrates how industrial waste can be transformed into useful energy resources. The experience has enhanced our understanding of suitable engineering and the importance of renewable energy for environmental protection.